Hi, this is Maggie from Design Code to Bug Repeat. Welcome to the channel. In this video, we're going to look at 4 examples of branching or conditional programs in Python. If you have learned about Boolean logic, Boolean variables, and if, elif, else statements, these examples are perfect for you. If you want to learn along with this channel, this video is in the Learn Python Programming full course playlist. All of the example programs in this video can be downloaded from my GitHub repository. There's a link in the description. You're going to learn best if you try to write these programs yourself. So for each example, I'm going to tell you the problem, and then I'm going to suggest you pause the video and try to write the solution yourself. If you don't have Python installed, well, you should, but you can also write each program by following the code check links in the description of the video. And when you click the code check button after writing the code, your program will be run on test data. This will give you a good idea of whether you've solved it correctly or not. I'll then show you my solution, and as a final bonus, I'm going to show you some context, a larger program that uses the code we've written as well as a graphical user interface and a Python built-in library as part of the solution. I know it's hard when you're learning to program to see how the simple programs we start with fit into the larger software development picture. So I'm hoping this will offer some fun and motivating context, even if it doesn't completely make sense at this time. Stay with me on this channel, and it will. Let's jump in. Program 1, validating a date. For this program, you will help the user make an appointment, obtain the day and hour of the appointment they want, validate that the hour is between 8 a.m. and 4 p.m. That is not as simple as it sounds, so think about different hours that are correct and are not correct, and make sure your program works for both correct and incorrect entries. You should also validate that the day of the week is Monday through Friday. I have 4 examples of the program running here, because there are 4 different possibilities for the inputs for which the program should have 4 different responses: good day and good time, good day and bad time, bad day and good time, bad day and bad time. The prompts are what is the day for the desired appointment, and what is the hour for the desired appointment, 8 to 4. If the user enters Monday at 1, good day, good time, the program responds, we'll see you on Monday at 1. If the user enters Monday and 7, good day, bad time, the program responds, please schedule your appointment between 8 a.m. and 4 p.m. If the user enters Saturday and 8, bad day and good time, the program responds, please schedule your appointment for a weekday. Finally, if the user enters Saturday and 7, bad day and bad time, the program responds with both error messages. Pause the video and write the program in idle, or use the code check linked in the description. How did you do? Here is my solution to the problem, called makeappointmentsolved.py. I have 3 variables: day, a string, hour, an int, and status message, a string. I chose to put the status message in a variable and then print it at the end of the program, partly so I can add as many error messages into it as I need. This isn't necessary. You could print the messages as you encounter error conditions. However, as much as possible in my programs, I tried to separate the human-computer interface components from the computing part of the program. If I wanted to change this program to put the message in an error box in a graphical user interface, it would be very easy to do because all of the errors are in a string. I wouldn't have to comb through the logic to find and change print statements. I prompt the user for the 2 inputs and read them into the variables day and hour. Then we have the logic part of the program. There are different ways you could write the logic for this. I chose to use nested if statements, so the logic is a little simpler. In the outer if statement, I check if the time is valid. I have to do that in 2 checks because the valid times fall around noon. So I have 2 checks for a value within the range of 8 to 12, and within the range 1 to 5. When we're checking for a value in range, we use an AND statement, and we check that the variable is above the lower range value and below the upper range value. But the value can be either in the 8 to 12 range or in the 1 to 5 range, so I join those with an OR. So my logic is if hour greater than or equal to 8 and hour less than or equal to 12, or hour greater than or equal to 1 and hour less than 5. That is a good time. Under the if, we must then handle good time, good day, and good time, bad day. So I have another if statement, and I chose to check that day was not Saturday or Sunday with day not equal to Saturday and day not equal to Sunday. Note that it won't be syntactically incorrect if you write day not equal to Saturday and Sunday, but that is completely wrong. You need to have an expression that evaluates to true or false on either side of an and the same with an or. If I write day not equal to Saturday and Sunday, Python is considering the string Sunday to be a complete logical expression, and it's always true. I have a video on this that I'll link here so you can understand exactly what's happening when you write incorrect logic like that. It's a tricky error because it is syntactically correct, and it is how we speak naturally. So if we have good time and good day, I set the message to the good day, good time message. If this were a real calendar program, we'd also create the appointment, whatever that would entail for our program. In the inner else, that means we have a good time and a bad day, so I set the status message to please schedule your appointment for a weekday. The outer else is the bad time condition, and we can set the message to the bad time message. But then we'll want to add to that message if it's also a bad day. So I have an inner if that does the same check for a bad day and appends the bad day message to the bad time message with plus equals. Finally, at the end, I print whatever the message is. You might have structured this differently. For example, you could structure this as one long condition for correct day and time, and then an elif with a condition for correct day, for example, meaning the time would be incorrect, and then an elif for correct time, meaning the day would be incorrect, and finally an else, meaning both day and time are incorrect. You could also structure this as separate if statements with the 4 different conditions, one in each if statement. That would work, but it is not as good a structure for 2 reasons. One is that all 4 if statements will always execute because they're separate if statements, and that's inefficient. The other is that it's not communicating the mutually exclusive nature of the conditions. These conditions are tied together. No 2 of them can be correct at the same time. You want your code to reflect that reality by using an if-elif or if-else structure. Code is read more than it's written, a quote from Python's creator, Guido van Rossum. We want the structure of the code to reflect reality, not obscure it. Now, before we look at a real-world context for this program, I'm going to give you a second related problem that is going to require an if statement. Program 2, converting a 12-hour clock hour to a 24-hour clock hour. Obtain a time, an integer between 1 and 12, and either AM or PM from the user, and convert that time to a 24-hour time. I have 4 examples of this program running, the 2 12 o'clock special cases, and an AM hour and a PM hour. The prompts are what is the hour, 1 to 12, and is that AM or PM. If the user enters 12 and PM, the program responds 12 PM is 12 on a 24-hour clock. If the user enters 12 and AM, the program responds 12 AM is 00 on a 24-hour clock. I've chosen to format the 24-hour time with a prepended 0 if it's 1 digit. If the user enters 1 and AM, the program responds 1 AM is 01 on a 24-hour clock. If the user enters 1 and PM, the program responds 1 PM is 13 on a 24-hour clock. Pause the video and write the program in idle or use the code check in the description. How did you do? Let's take a look at my solution called 12 to 24 solved.py. I have 3 variables, 12-hour and 24-hour, both ints. I'm keeping the old time separate from the new time for clarity. Sometimes we want to keep our inputs around, so it makes sense to have a new variable for computed results. I then have a string, AM_PM. I then obtain the 12-hour time from the user. For the conversion code, I'm again using the principle that these are mutually exclusive times. If it's 12 AM, it can't be 3 PM or 6 AM or 12 noon or any other time. Only one conversion will be appropriate for one execution of the program. I want that reflected in the data structure I've chosen, so I've chosen an if, elif, else. For my if condition, I have if 12-hour is not 12, and AM_PM.lower equals PM. I am comparing a lowercase version of what the user enters in case they enter an uppercase string. This case is an afternoon time that isn't the special case of 12 noon. For those hours, I'm adding 12 to the hour given and assigning that into 24-hour. So 1 p.m. becomes 13, 2 p.m. becomes 14, etc. The next special case is 12 midnight. So I have elif 12-hour equals 12 and am pm.lower equals am. In this condition, I set 24-hour to 0. For all other times, which include all morning times and 12 noon, the 12-hour clock value is correct. So in else, I have else 24-hour equals 12-hour. As with most programming code, there are many ways to solve this problem. If you have thoroughly tested your code and you always get the correct answer, then your solution works. In this example, you could test with all 24 possible times from 12 midnight through 11 p.m. and confirm without a doubt that your code is correct if given a meaningful input. And there is also more than one solution that preserves my principle of using a structure that reflects the structure of the problem. Times are mutually exclusive, so we should use an if, elif, else. You might have tested the conditions in a different order or chosen to test morning and 12 noon in one of your tests and left a different condition as the default. Or you could have tested the two 12 cases completely separately from the rest. There are many possible solutions to most programming problems, especially once our problems become more complicated and involve branching. And again, before we look at a real-world context for this program, I'm going to give you a third related problem that is going to require an if statement. Program 3, checking that one date falls before another. When you make an appointment, it has to be in the future. Write a program that obtains a year, month, and day from the user and determines if that value is in the future. Use year, month, and day constants to represent the current date. When the program runs, it will print a message. Enter a date and I'll tell you if it's in the future. And then it has the prompts, enter the year, enter the month, enter the day. For the date May 16th, 2025, if the user enters 2025 5/16 at the prompts the same day, the program responds with not in the future. It gives the same response for an earlier year and an earlier month. For a date in the future, such as May 17th, 2025, it prints back to the future. Pause the video and write the program in idle or use the code check in the description. How'd you do? Let's take a look at my solution called 12 to 24 solved. I define the constants using the date that I'm recording this video, May 16th, 2025, and I annotate the three variables for the user's date, user year, user month, and user day. I've also annotated a Boolean called inFuture. I've then obtained the date values from the user. Now, to determine if that date is before or after the current date, I'm going to make use of the Boolean variable inFuture. I'll begin by setting that to true, and then I'll compare the user-entered values to my constants to set it to false if the user values fall before the current date values. So I begin with the year. If user year is less than the current year, the date is not in the future, and we're done. So if user year less than year, inFuture equals false. Now, if it's not, it's either the same or it's greater. We are only looking for ways to set the variable to false here, so I check with an elif user year equals year. If it's the same year, then we'll need to check the month and possibly the day. There are three possibilities for the two year variables. Either the user year is less, it's the same, or greater. We only need to consider less or equal. So if it's equal, I'm then checking if the user month is less than the current month, and if it is, inFuture is set to false. Again, the user month can be less, equal to, or greater, and we only need to consider equal to now, so elif user month is equal to the current month, we'll have to check the day. Now for day, we can check all in one condition. If user day less than or equal to day, inFuture is set to false. All of the other conditions are conditions for which the date is in the future, the default value we gave to inFuture. Sometimes it makes sense to set a flag to a default condition and then flip it. Another example might be checking for invalid input. You might assume all input is valid, and then as you're obtaining input, flip the flag if you encounter invalid input. Here we're assuming the date is in the future, but as we check year, month, and day, we're flipping it if we find a value that's not in the future. I have used an if-elif structure because of the mutually exclusive conditions of less than, greater than, and equal to. After the logic, I'm checking the flag and then printing the appropriate message. Because in future is a Boolean variable, I only need to write if in future. In future is a Boolean variable, so it is a very simple Boolean expression. It evaluates to true or false. Many folks, when they're learning programming, want to write if in future equals true, or if in future equals false. This is a bad habit that you should avoid. Remember that a Boolean variable is itself a Boolean expression that evaluates to true or false. Instead of writing if in future equals false, write if not in future. Now, I'm going to combine all three of these programs into one appointment-making program. Making an appointment is a real-world context already, but dates and times are so complicated, you would generally use a datetime library to handle comparisons and calculations. And to select a date, it's much more likely you'd have the user choose from a calendar picker, so they wouldn't specify an invalid date, such as February 30th. Using a calendar picker and the datetime library, we won't need all of the complicated logic that we've written for the three console programs, although you will see some of our logic here. But your time was not wasted. Writing these programs is excellent practice for thinking through and writing conditions. You may not have to write code like that for calendar dates, but you will have to write it for custom programs. This version of the program is called makeAppointmentDateTime.py because it uses Python's datetime library. That comes with your Python installation. I'm also using PySimpleGUI for the graphical user interface, so if you want to run this program, you will need to install that library. The datetime object allows us to compare dates and times, easily format them for printing, and get information about them, such as what day of the week a certain day falls on. I'm going to run the program first. I get a little appointment scheduler window. When I click the Pick Date button, I get a calendar picker. I'm going to choose Sunday, May 11th, because that's both in the past and on a Sunday, both invalid for an appointment date. Once I've chosen that, we can see the date in the Select Date box. There are spinners for choosing a time and a combo box for choosing AM or PM. I'm going to pick 7 AM because that is an invalid time. And then I'll click the Make Appointment button, and I get the 3 errors with my appointment in the box below. Let's look at the code. Lines 39 to 53 create the graphical user interface. So that is basically a list of PySimpleGUI components that will be put into the window. If you continue learning Python from this playlist, you'll learn about lists, and I have PySimpleGUI videos on this channel as well. From lines 57 to 102, we have an event loop. We will learn about loops next. An event loop waits for the user to interact with the GUI and then responds to the user's actions. We only need to respond to the Make Appointment button press here because we want to validate the date and display a message based on that press. Notice there's an if-elif. This is standard inside an event loop. We check each action the user might have taken and handle that action in the conditional code. Our if is handling a click in the close box ending the program. Our elif is elif event equals make appointment. This is our validation code. We first make a datetime object. A datetime object will represent a specific date and time. The first one we're making is just the date, called selected date. We're pulling the date value out of the GUI and creating a datetime object with it on line 64. The next block of code from lines 67 to 73 should look familiar. We're pulling the hour, minutes, and AM, PM out of the graphical user interface and then converting from 12-hour time to 24-hour time. You can see that we still need some of our logic to work with the datetime class. We then combine the original date with this time, creating a new datetime object called appointment. But now we can take advantage of this object to make our validation simpler. We can create another datetime object called now and simply check if the appointment is before or the same as now. If it is, the appointment is not in the future. So you can compare datetime objects with the equality operators. This is a little syntactic sugar that Python includes that allows us to create complicated objects like datetime, but then write code so that we can use built-in operators like less than and equals on them. So our check for the date being in the past is as simple as if appointment is less than or equal to now. To check that the appointment is between 8 and 4, we use appointment.hour, which is a 24-hour time. So we only need to write 8 less than or equal to appointment.hour and appointment.hour less than or equal to 16. And we can get the day of the week from the appointment. It will be a number between 0 and 6, where 0 is Monday and 6 is Sunday. So we can just check if that value is greater than or equal to 5 with appointment.weekday greater than or equal to 5. And if it is, we know the appointment was made for a Saturday or Sunday. We can also get that value as a string if we want to check against the strings Saturday and Sunday. I'm using a Boolean flag here and setting it to true before we validate, and false if the appointment is invalid in any way. If it's valid, I set the message to "We'll see you on" and whatever appointment date they set. But otherwise, I'm appending each error message into the final message so the user knows everything that's wrong with their appointment before they try to make another one. Whenever I give my students a date or time program to write, I think they're a little frustrated because they know the computer knows the date and time, and they should be able to get those values from the computer. You can. You can see it right here, now equals datetime.now. But you can also see there's a lot you need to learn before using the datetime object is going to make complete sense. You need to understand objects and methods at a minimum. So we usually start with simpler programs, like the first 3 in this video. I wanted you to see where you're headed, writing that kind of logic, and how it fits into a more realistic program. So I hope you found these examples interesting and helpful, and that you were able to program the first 3 yourself. If you found them challenging, try again, and check back with the video if you get stuck. The code solutions for these programs is available in my GitHub repository. There's a link in the description. As always, have fun and keep coding.